Hello everyone who has joined us today for this two-day marathon of science, art, synesthesia, and specific for this event, education. Tests, exams, ratings, and placement, we know that education is largely dependent on measurement. We know even better that verifying one's congenital synesthesia can also start with measurement, which can define one's learning experience and determine one's education trajectories.
These are the two topics I will try to join in my talk today: synesthesia and measurement. Measurement of something seemingly ephemeral, and this is about all measures in the science of human psychology. All these measures make you ask more questions than they are supposed to give answers to. Indeed, those 21.3 grams that Duncan McDougall, a physician from Massachusetts, claimed to identify in 1907 for the mass of a human soul, immediately raise a question: if it's for better or worse if this ephemeral entity of yours, in some whimsical manner, gets dismissed from the worldly office a bit overweight or, the other way around, undernourished. Synaesthesia quotient is a notion that I thought of as a useful idea that we can develop and apply to find out to what extent an individual synesthete's brain is synesthetic in comparison to another synesthete. In other words, if someone can have a better memory, or if your mathematical abilities can be measured, why not synesthesia? Indeed, synesthesia is an all-or-nothing phenomenon only if you do not have it. But if you're lucky to have it, you may have 1, 2, or 10 types of synesthesia. And despite the fact that the mere number of manifested types does not tell the whole story, this is how the idea of measurability of synesthesia came about almost 10 years ago. If you look deeper into synesthesia, by splitting it and comparing its subjective qualities across the recorded cases, you start revealing its other propensities. This method of analyzing synesthesia within the framework of neuroscience, or what I call neurophenomenology of synesthesia, helps quantify its manifestation. Altogether, synesthesia quotient is designed to embrace 10 characteristics: number of types, cognitive similarity of inducers, qualitative richness of concurrence, lifelong diminution of their perceptual presence, intensity of projectile qualities of concurrence, inclusivity and scope of inducers, immediacy and embodiment of inducers, attention engagement or sentience of inducers, deliberate suppression or controllability, and veridical presence of inducers. These aspects can be summed up into 3 overarching ones. So, besides identifying the sheer number of types, such as grapheme-induced or music-based or spatial sequences, it includes how selective or semantically mediated those present types are. Simply put, how cognitively similar or distinct the inducers are. The third aspect is embodied immediacy, or how neurophysiologically pervasive the individual synesthesia is, which again translates into more intense activation of the proximal, chemical, mechanical, or internal senses, as opposed to the more distant senses. So synesthesia quotient implies a measure which quantifies synesthesia through neurocognitive mechanisms. And if you're a synesthete, you can measure your case on the basis of 10 subscales of 5 points each, thus getting a SynQ from 1 to 50. This was my initial idea, and after that, several articles on synesthesia quotient concept and application were published. I will show you in some minutes why this notion of synesthesia quotient and the related measure can be important.
As far as we know now what synesthesia quotient is, let us go from a slightly new start.
We know that people with synesthesia not only have unusual perceptual experiences, but their memory, perception, and broad personality traits can also be different, which in turn can influence their preferences, attitudes, or life choices. This set of qualities is called a cognitive profile. What if we gather some real big data about some large group of random people and try to identify who of them is a synesthete and who is not? Can we do this? Actually, we can't, because so far we do not have an exact algorithm that reliably predicts this only by the input data. It's like a chicken and egg issue, to solve which we need to know in advance who of those people are synesthetes. Is it a dead end then? Not at all. To figure it out, we first need to play this game with a smaller, more manageable group, about whose members' synesthesia, or lack of such, we do know about. Then you find an algorithm that can be applied for our purposes, that is, to identify synesthetes in a random group among random people about whose synesthesia you have no prior knowledge. For designing such an algorithmic model, we recruited 55 subjects with synesthesia and 55 controls with matching demographic characteristics. As usual, both groups took the synesthesia battery, so we could tell synesthetes from non-synesthetes. After that, both groups took other psychological measures. All in all, they took more than a dozen tests, embracing 40 subscales based on a broad area of research into synesthetes' cognitive styles, temperamental traits, sensory inclinations, and so on. This is 44,000 units of data about both groups of synesthetes and non-synesthetes. To estimate the probability, if an individual's case falls into one of the two categories of a dichotomous dependent variable, in our study it's possessing or lacking synesthesia, we applied binomial logistic regression. Binomial logistic regression, to put it very simple, is a statistical algorithm that helps researchers boil down all the data in their pool to find out to which one of the two groups each particular subject of your research belongs to. And you identify not only which of the two groups the subject belongs to, but also with what probability. To give you a metaphorical understanding, imagine you have multiple drivers going to destination A or destination B. You do not know where they're going to, and neither may they, because it may all depend on minute-by-minute choices, and those drivers' ample skills, variety of their plans, backgrounds, and so forth. And you know all this critical information, all their little secrets and whatnot, and when it's all processed, you come to know who of them and with what chance will get to destination A and who will arrive at destination B. As a result, we build up a model of prediction with good statistical validity, with a high value of multiple determination. The overall probability of correct predictions in our model is 83.6%. Within the model, we identify that 4 specific subscales can yield dependent variables that have statistically significant values. And all in all, we arrived at a summative equation, which is this. To emphasize this, the model helped single out 4 specific subscales. These were experience seeking, psychomotor plasticity, tolerance to ambiguity, and psychological boundaries. This means that these scores can work as reliable predictors, with the probability of having synesthesia in each individual case estimated by using this equation. In a more practical way, if we want to predict if some particular subject does or does not have synesthesia, the maximum contribution to this prediction will be made by the experience-seeking scale. Then, proportionately, the second most significant contribution will be the score on psychomotor plasticity, followed by tolerance to ambiguity. The least contributive here will be the psychological boundaries measure. As it was originally conceptualized by the authors of these inventories, experience seeking stands for a subject's inclination to strive for non-conventional, risk-free experience. Psychomotor plasticity implies how fast one is able to switch from one physical activity to another. Tolerance to ambiguity is exactly what it says it is, an inclination to more readily embrace controversies, while psychological boundaries is a broad trait that pervade your personality and show how strictly or loosely you separate inner from outer experience, sleeping from waking, past from present.
As long as we know the predictors and the values, can we say for sure that these traits are related to congenital synesthesia? Related, yes, but we do not know how tightly synesthesia and these traits are connected.
To specify this, we cannot be quite certain if these traits are only codependents and develop as compensatory or complementary traits, or these traits are based on the same neurocognitive mechanisms common both to these traits and congenital synesthesia. It's just an objective for which synesthesia quotient comes into play, to identify if those four subscales have immediate correlations with the degrees of synesthesia in individual cases. We applied synesthesia quotient and Spearman's correlation analysis. For this, we used a simplified synesthesia quotient, reduced it to the number of types and the cognitive similarity or distinction. As a result, SynQ1 is when there is one type or two cognitively similar types of synesthesia. 2 is three similar types or two cognitively different types. A SynQ of 3 points is four similar or three cognitively distinct types, and so forth. Thus, we have quantitatively ranged the individual degree of synesthesia from 0 to 4, where 0 stands for absence of the condition in the control group. Of 40 subscales, we found that 6 scales correlate with SynQ positively and 5 negatively. Analysis yielded a profile of synesthetes which embraces links with neuroticism, intellectual tempo, overall intellectual activity, novelty aversion, tolerance to ambiguity, and psychological boundaries. Negative correlations were found between synesthesia and psychomotor endurance, psychomotor tempo, intellectual emotionality, thrill and adventure seeking, active value, passive behavior. Overall, a profile based on correlations with synesthesia is important in and of itself. Unlike our earlier ones based on group differences, such a more dynamic correlation-based profile implies that observed synesthesia-bound characteristics increase or decrease alongside increase or decrease in synesthesia itself. As a result of such synesthesia quantification, in our study we see trends in background neurocognitive intensity, more intellectualization versus physical involvement, less compartmentalized or less rigid subjectivities, but increasing consciousness of new and risky situations. Among other conclusions, we see, by what did not show correlation, that broad factors such as overall activation or inhibition of behavior are hardly involved in impacting synesthete's profile. Instead, there are more subtle, more selective, and combinatorial determinants at play. As we see here, only 2 of the 4 predictors have been found to correlate with synesthesia quotient. These are tolerance to ambiguity and psychological boundaries. Both correlate positively. Why only these 2 traits happen to be both correlates and predictors? We can hazard an educated guess that, all other things being equal, while the predictors in the regression model are predictors of synesthesia only in proportionate combination with each other, those 2 correlating predictors can work in this function all on their own. That is, they can be independent predictors.
Of course, our results may fail to be universally generalizable, because the initial types of synesthesia were grapheme types. So it may work differently if we have a sample that had no representation of such types. Second, by calling some characteristics predictors, we need to remember that our statistical limitation falls into an 83.6 probability, very high, but not, of course, as sure as hell in Texas. On the other hand, we can legitimately discuss those traits that demonstrate correlation with synesthesia as concomitant formations determined by the same neurophysiological propensities.
To sum it all up, synesthesia quotient is an important notion. It informs a necessary, viable, and long-awaited quantification tool because it can be a cornerstone for further serious research into synesthesia. It implies that we can compare individual cases of synesthesia on a gradable scale. We can reveal both positive and negative correlations of synesthesia with other individual characteristics. We can build up more dynamic cognitive profiles that can be further juxtaposed with individual differences in brain neurophysiology. And as we have demonstrated today, synesthesia quotient can be used for reliably and more distinctly identifying psychological predictors of congenital synesthesia. Duncan McDougall, the soul-weighing physician, was blamed for underreporting his findings. The thing is that some of his less collaborating subjects varied their post-mortem weight, though not losing but gaining hefty amount of body mass, which was lost again over time until returning to the initial weight. Those underreported measures can encourage some obstinate scientists to snap a conclusion that there are no such entities as souls at all. But others, though, can be shrewd enough to conclude that regarding the matters of life and death, at least some specimens of the human race can be measurably indecisive. When time permits, you can take the synesthesia quotient test by following the QR link. Thank you for your attention and contribution.